equation for this one? Is that what they
Yeah.
want? Okay.
Yes. Sorry, it's a
So
very blurry picture.
that's all right. So the equation would be, oops, hold on. All right, the equation for this one, in order to find the equation, you want to find, these are just points that kind of help you determine what your line is. So that point, we'll use these later, is 2 comma negative 2, right?
Yeah.
This point is 0 comma negative 2. And so you can see that this line right here is your asymptote. And what's the
Yeah.
equation? That line is what?
X equals 1.
That x equals 1. And then you can see that we have a horizontal asymptote at what?
Y equals 0.
Right. Now, when there's a horizontal asymptote at y equals 0, that means that it's a bottom heavy function, meaning the denominator has a higher degree than the numerator. Okay.
Oh.
So that's the first thing to remember. And then when you see them going in the same direction toward an asymptote, that means that that particular asymptote has multiplicity 2. So I know that in the bottom of my equation, I'm going to have x minus 1. You understand why I'd have x minus 1?
Yeah, because it's the asymptote.
Right? But then I have to square it.
Okay.
And then I have no x-intercepts, or at least it's kind of blurry, but it seems like there's no x-intercepts. Is that right?
There's
Are
none, yeah.
Okay. So we might have just the number 1 might be on the top, but a safe thing to do is to write an a up here and then solve for it to make sure that we have the right function. So let's plug in 2, negative 2, and find out what we get for a. Plug in 2, negative 2 to your function. So 2 goes in the x, negative 2 goes in the y. So your equation would be negative 2 equals a over 2 minus 1 is 1, which is 1 squared. So a equals negative 2. And let's make sure that's the same thing you get when you plug in 0. You should also get 0, negative 2, right? So 0 minus 1 is 1 squared. And yep, sure enough, I'll get negative 2 equals a. So my equation, so what I can do now is I know that a equals negative 2. So y equals negative 2 over um, x minus 1 squared.
All right.
And that would be your equation. So probably the hardest part is to find out what your a is, but that would be the easiest, the quickest and easiest way to do it. Make sense?
Yeah.
All right. So on the next page, stop me if I'm going too fast, but you can see the points are um, this point is 0 comma 1, right? 0 comma 1 is one of your points.
Yeah.
0 comma 1. Here's another point is negative 3 comma 4. You can see you have a vertical asymptote at x equals negative 1, and you have a horizontal asymptote at y equals 2. So when you have one at y equals 2, that means the ratio of leading coefficients is going to be 2 over 1. So I'm just going to write 2 on the top and 1, which I won't need the 1 on the bottom, but I'll write the 1 on the bottom for now, right? My vertical asymptote is going to be found by setting this equation equal to 0. So x plus 1 is in the denominator. X plus 1 is in the denominator. And then this is my x, my 0 or my x-intercept is going to help me find the numerator, where the numerator equals, or a factor of the numerator. So x minus 1 is a factor of the numerator. Does that make sense how I did that?
You explain like why did you get 2? Like how did you get 2 in the numerator? Is that like a rule for every
The
number? Like
reason,
if it was y equals 3, would you put 3 on top? Or is
yes.
that just okay?
Well, if it was 2/3, you would put 2/3 like that. The vertical or the horizontal asymptote, when the horizontal asymptote is a number other than 0, that tells you what that the degrees are the same. of the top and the bottom. See how they're both degree 1? And it also tells you you just take the leading coefficients basically.
Okay. That makes sense.
And so let's make sure this is correct by plugging in the point -3, 4. So -3, if I put -3 in for x and 4 in for y, would that work? Let's see, -3 minus 1. -3 minus 1 is -4 times 2 is -8 over -2 times 1, which is -2. And sure enough, that equals +4. Okay. So
Okay.
that's how you check it to make sure you did it right. And then of course 0, 1 will definitely work because we know that when you put in 1 here, you're going to get 0 on the top, and it doesn't really matter what you get on the bottom. You have 0 on the top, which 0 over anything is still just 0. That's the reason we built it that way.
All
Okay,
right.
make sense? All right, now
Here's
this
another
one's,
great picture.
yeah, that's fine. I can see it. Okay, this one's a little bit trickier because now we have a slant asymptote. So with a
Yep.
slant asymptote, that means that the degree, if the slant asymptote is a line, that implies that the degree of the numerator is equal to 1 more than the degree of the denominator.
Yes.
Okay, so it's top heavy, but just barely. So let's go through and talk just like we did before. So the first thing we're going to do is we're going to look at our intercepts. So our intercept is x. Sorry, the x-intercept is 0, 3. Is that right? The vertical asymptote is x equals 2. And the slant asymptote, looks like I have a slant asymptote here.
X equals 4, I believe. Right?
No, it wouldn't be
X
x
plus
equals
X
4.
it would be X equals 4. X plus 4, right?
Y equals, yeah,
X plus
x
4.
plus 4, because there's your y-intercept and the slope is up 1 over 1. Yep, y equals x plus 4. So here's how you do this. First of all, I know that the degree of the numerator is going to be 1 more than the degree of the denominator. I know that in the numerator rather, I'm going to have x minus 3. That comes from this, right? I know
Yeah.
in the denominator, I'm going to have x minus 2. X minus 2. That comes from this. But I know I have to have one more in the denominator, which I do, because here's another 0 I forgot to write over here. You see the other 0 is -5. 0, -5 is another 0. So that implies that I have x plus 5 as well in the top. Okay. And I can't really see what my y-intercept is, but it kind of looks like it's
It's
going to be
4.
maybe. No, that's not my y-intercept for the graph. The y-intercept for the graph is probably going to be like 8.
Yeah.
So 0, let's see, 0. I plug in 0 for all the x's. If I'm hoping that this is it, and I don't have to put anything here, A or B here. So if I plugged in 0 for all of these, I would get -3 times 5, which is -15, over -2, which is -7.5. Yeah, that seems about right. -7.5 is probably the right answer. So I'm pretty satisfied that this is probably the correct answer. That's probably all you need to do. You don't have to put anything else there. Now,
All right.
to be safe, what you could do is you could find out has your teacher taught you how to find that slant asymptote? To find the slant asymptote, you would go ahead and multiply out the numerator. So x squared plus 2x minus 15. And then you would put x minus 2 into that. You would do long division. So how many times does x go into x squared? It goes in x times, which gives you x squared minus 2x. And then subtract that, and you will get 4x minus 15. And then x, how many times does x go into 4x? 4 times. and you get 4x minus 8 and subtract that, and you would get -7 as the remainder, which doesn't really matter. -7 over x minus 2. So that would be your answer. But your slant asymptote, sure enough, look at it. It's right here. It's x plus 4. And that's what our slant asymptote was. Okay. I don't know if your
Yeah.
teacher wants you to do that or has taught you that, but that's how you would do that. Make sense?
Okay. These
Next,
ones are a bit easier, but I know I basically know how to do that. I just wanted to like I
well,
guess
this
like
one's
for them again.
yeah, the tricky part about this one is there are no vertical asymptotes, but you do have a hole. So when you have a
Yeah.
hole at x at basically 3, 5, that means that implies that x minus 3 is a factor on the top and the bottom. So when I'm writing my equation, I'm going to write x minus 3 on the top and x minus 3 on the bottom. That's how I got that hole. And then I use this and this to find my other. What's that?
I didn't say anything.
Oh, I thought I
I
heard
must
say
have like
something.
I think my hand was near the where the
Oh,
computer like the
no.
computer microphone, so it must have picked up some sound.
So if I get an x-intercept here, what does that mean?
It goes in the numerator.
Good. So x plus 2, right, would be in the numerator.
Yep.
And then the only other thing you have to do is make sure that you've got the right a sitting in front of this to make sure that you get this point right here, which
So
that
you
point 0, 2. So plug in 0. Now, actually, I don't have to plug it into here, right? Because remember that
oh,
x minus 3 is really just going to cancel out. So what I'm really going to do is write the equation y equals a times x plus 2, and I'm going to ignore the x minus 3 and the x minus 3 because those really just cancel each other out. And now I'm going to plug in 0 and 2 and find out what a equals. So 2 equals a times 2, which means a equals what?
yeah, one.
1, which is what I would suspect because these are not difficult ones. They're not trying to, they're not trying to make it too complicated for you. So a is just 1, but you really shouldn't assume that it would be 1, right? You should do that to make sure that it is 1, not just assume that it's 1.
Yeah.
Because remember, if there was if there was some other multiplier here, it really wouldn't affect it wouldn't you wouldn't really be able to tell because you don't have any asymptotes. This is really just a line with a hole in it, as opposed to these other ones where you like, oh, this is the more standard one where like the horizontal asymptotes and the vertical asymptotes are giving you lots of good information. We don't really have that in this picture. So just be aware of that. So a does in fact equal 1 in this example. So your answer is just y equals x, and they probably want you to write it. I don't know for sure, but they probably want you to write it like this: x squared minus x minus 6 all over x minus 3. That's probably how they want you to write it.
Yeah.
I don't know how the what the directions state exactly, but typically that's what they want. Make sense?
Yeah, it makes sense.
Okay, now let's do the one on the bottom there. So for that one, a little bit more standard, but we still have a hole here. So remember, what does that hole mean? That hole means I have a vertical asymptote. I'm sorry, I have a factor of x plus 4 on the top and on the bottom.
It's plus one. Wait, no. Oh, okay. I'm stupid. Sorry.
Right? That makes
Yeah.
sense? Plus 4. So let's start by putting an x plus 4 on the top and on the bottom. This, do we have any x? We don't have any x-intercepts. we do have a y, we do have a vertical asymptote, which is x equals -3. So what does that mean? What factor do I have and where?
Um, the x minus 3 goes in the denominator.
Not x minus 3,
X plus 3.
right? Do you understand why?
Yeah.
Okay. And then again, just to make sure, let's just plug a little a in here and let's make sure that this point, let's find out what a is going to be. So that point is -2 comma 1. And let's make sure that when we plug in -2 for all the x's and 1 for the y, let's make sure, well, let's solve for a basically. So 1 equals -2a all over. This would be 2 and this would be 1. So 2 times 1 is 2. So the 2's cancel and I just get a equals -1. So I actually have to have a negative. A is actually just -1. So my answer is just y equals -1 times x plus 4 all over. And again, you can multiply this out. So it would be x squared plus 7x plus 12. And probably you can multiply this negative in here as well. -x minus 4. So that it's in the form that they probably want you to write it in. Okay.
All right.
Probably have time for another one. You have another question, or you
No, I don't.
feel pretty good?
Yep.
All right. Well, you know where to find those that video.